Okay, so now we are going to do something much more sophisticated. You can think of the struct, you were in the minor leagues, and now you're in the major leagues with what we're about to do. And what we're about to do is object-oriented programming. Now look, you've been doing object-oriented programming since your very first day of class. Of the first day of the semester, but in that case you have been using objects that are already defined in the C++ standard library. Now you're at the point where you're going to be able to design your own objects and start using them. So I'm going to just keep going with the student example, and we're going to ultimately create a student object in memory. Now, creating an object in memory, I want you to put programming out of your mind for a moment and think about if you were going to build a house. If the idea pops into your mind to build a house, what's the first thing you're going to do? I'll tell you what you're not going to do. You're not going to just drive over to Home Depot and start buying some wood and some nails and just go out into a field and start hammering things together and hope it works out. What you would do is maybe hire an architect who would come up with a plan for your house. Okay, so every sophisticated object in reality, say a house, a car, some sort of appliance, starts with like a detailed design. And that's really the mindset you're going to take when you're creating objects in memory. Every object starts with a design, and that design is called a class. And I have my student class in place. I'll just pick it apart little by little, but I just want to do a quick scroll here and show you how long it is. This is the end of the class. Again, I'm up above main here, but this is, 42 lines of code, give or take. And that's my student class. Now remember, the struct in the last video was just like maybe 5 lines of code. It was like a tiny thing up at the top. So I have my student class, and this is this section here, the private section, is where we put what we call the data members, or the these are called instance variables. I think your book uses that term more so than data members. The private data members, or the private instance variables, and these are the variables that make up the class. They're like the members of the struct that we just talked about in the last video. So those are your private data members. And now we're at the point where we have to start thinking about things like private versus public. Private in programming means the same thing it does in real life. Okay, when you're in private, for example, you're in your house, the blinds are closed, the doors are shut and locked, and nobody can get at you. Nobody from the outside can get at you. And so when you make your data private, your data is like locked up in the class. It's locked up inside of the object. Ultimately, we're going to have an object based on this class. And it's protected. It's protected from any kind of outside corruption, be it, other functions in the program, or other functions, solution-wide. Our programs are always just the one code file, but in reality, programs are very complicated. Tons and tons of files, tons and tons of functions, and so when you make your data private, it's more secure. Okay, so that's good programming practice. So we have our private data, and I just want to, so at this point, up until here, it kind of looks like the struct we were talking about. Let me go down to main before I talk about the rest of this, and I've created a student, which I'll call HP, based on my student class, my new data type that I've defined, which is student. Now I'm going to create an object based on that student. And this is a subtle distinction, but I want to mention this. When you are defining the instance variables, or the data members here, you're actually not setting aside memory. I want you to think about the house analogy again. If you have a design, the architect hands you a design on a DVD or something, you have not set aside any space in the physical world yet, apart from the DVD. You don't have any rooms or square footage at that point. All you have is a plan. And that's what we have at this point when you're typing out the class. You're not setting aside memory. You're just describing what the memory will look like if you decide to create an object based on that class, based on this class. And so when I go down to main, And I'm finally creating an object based on the class. I'm calling that object HP. Now the student is created in memory, and I'm setting memory aside to hold the name, the house, the number of points, and the major. So it's subtle, but it's an important distinction, especially for computer science majors. So okay, so getting back to that dot operator that we talked about in the last video, when we were doing the struct, I was able to just say something like this. I was able to come around and populate the member using the dot operator, and you can see the compiler is complaining. So when I hover over this, look at the sign that's popping up. It's saying that the student name is inaccessible. Okay, and what does that mean? This traces back to the private specification. Okay, as I said, when you're in private, you're locked up in your house. No one knows you're in there. And so when I make data private, and then I come over to main, I can't just reference those data members, the name, the major, the, what else, the points. Main can't see into the class. It can't see those private data members, at least, because they're hidden inside of the class. Again, that's good programming practice. You generally want it to be like this. So this isn't going to work. So if I can't access those data members, they're basically useless. How am I going to get meaningful data into those data members? We have to provide some kind of backdoor access. And that's what I've done with these member functions. They are public. They are exposed to the outside world. So when I go to main, I go down to main, I can call those functions with the dot operator, the part of the class, part of the object. I can call those with the dot operator, and they are going to execute. It is going to work. And so all I've done here is I've added two functions, a setInfo function and a printInfo function. SetInfo will allow us to set the student's info to meaningful values. I'm just going to ask the user to enter the name, enter the house, and so on. And I've noticed I forgot to ask for the points here. I'll add that later. But this is called a mutator function because it actually changes the private data in those, it changes the data in those private data members. It'll change the values. And so in any case, that is a setInfo function. And then I also have a printInfo. It's like once I put the data into those variables, it would make sense to want to get it back out and maybe display it to the user, or, display the student record as we're doing here. So I just did a printInfo with some cout statements. And, this is a key point here. I have access to these data members. This should be house, and this should be major here. Okay, and then I'll add the points after I'm done filming this. But basically, we do have access to the private data inside of the class. And again, think about like being in your house, being in private. Other people, like your family members in the house, have access to you. They know that you're there. They have pretty much full access. And the same thing with the class. So you think of your class as a house, and the private data is, hidden inside of the house. The public functions, the public member functions, do have access to that data because they belong to the class and they're inside the house. They're like the family members. But private data cannot be accessed from outside of the class. So really, again, that comes down to the member functions providing some kind of indirect access or some backdoor loophole to be able to use those data members. Otherwise, the data members themselves would be completely useless. So we have just some couts here with the printInfo, and just reaching right into those data members because we have access here because we're inside the class, inside the house, and it'll print out the student record at that point. So lots of little subtle things, in this video talking about object-oriented and objects and classes. I don't expect you to remember everything immediately. I'll do another example after this, and hopefully some of these concepts will start to stick.